Hello guys, welcome to Roland High School Math Room, where we make high school math education very interesting and understanding. Today our studies is on quadratic functions, a complete introduction with graphs, turning points, and real-life applications. Now, what is a quadratic function? A quadratic function is a polynomial of the form f of x equal to ax squared plus bx plus c, where the coefficient of the x squared, which is a, is not equal to 0. So the graph of a quadratic function is a parabola which opens towards the positive or negative y-axis. So you can compare these two particular graph sections here. One of them is opening towards the positive y-axis, and the other one is open towards the negative y-axis. And this curve is known as a parabolic curve. That is a curve in the form of a parabola. The a, which is the coefficient of the leading term, that is the x squared in the quadratic function, indicates the direction and the width of the parabola. The b affects the axis of symmetry, that is the symmetry of the parabola. Then the c, which is the constant in the quadratic function, indicates the y-intercept. So when you look at this particular example, we have y equal to x squared plus 5x plus 6. So look at the coefficient of x squared, and the coefficient of x squared is positive 1. So you can see the graph opening to the positive y-axis because the coefficient of the x squared is positive. And look at the other one too. When you look at the coefficient of the x squared, it is negative 1. So as it is negative, it makes the graph open towards the negative side of y. So this graph is a parabola which is open towards the negative side of y. What happened? It is because the coefficient of the x squared, which is the a, is negative, and it opens towards the positive side since the coefficient of the x squared is positive when it comes to this particular example. So when you look at the first example too, the constant term is 6, which indicates the y-intercept. So let's look at this particular graph. Look at the movement of the graph. The part which the graph intersects the y-axis is the point where y is 6. So it makes the constant term 6 to be the y-intercept. And when you come to this particular example that we have here, the constant term is 1. So it means that the movement of this graph is going to intersect the y-axis at the point where y is 1. And this is the concept and the understanding and the definition when it comes to quadratic function. Let's look at the shapes and direction of the graph of quadratic function. Per what we've studied, we've realized that it is in the form of a parabola which opens upwards. So in this case, we are talking about U-shape, and you only get the U-shaped parabolic curve only if a is greater than 0, that is a is positive, which means that it is going to open towards the positive y-axis. And we also have the N-shaped parabolic curve. It only happens when a is negative, that is a less than 0. So the U shape is said to be the minimum curve, and the N shape is said to be the maximum curve. The direction depends on the sign of a. So per the example that we just saw from the two graphs, the direction of the graph was depending on the sign of A, which means that when the sign is positive, the graph faces the positive y-axis. And when the sign is negative, the graph faces the negative y-axis. Now, let's look at the part of the quadratic curve. Let's look at the part of the quadratic curve. So we also have another graph of a quadratic curve in this particular form. What are the part of this particular graph? We have the vertex, and the vertex is known as the turning point of the graph. And when you look at this graph, this particular point here becomes the vertex or the turning point. The turning point is also known as the maximum or the minimum point. And we have the end shape or the maximum point, which is what? The U shape. So the U shape is the minimum point, rather, and the end shape is the maximum point. That is what we need to take note of. So for this particular graph, it is in the form of U, which is facing the positive y-axis. So for this graph, its coefficient of x squared will be positive. At the same time, the graph is having a U shape, and U shape means that we are talking about minimum point at the turning point. So here the turning point is also known as the minimum point, and it's also known as the vertex. So this particular point is called the minimum point, the vertex, or the turning point. Then we also have the axis of symmetry, that is the vertical line calculated as s equal to minus b over 2a. So that is the vertical line that is in the form of a fraction of minus b divided by 2a. We have the y-intercept as c. So here the graph is intersecting the y-axis as at the point where y is 1. So you can see the 1 here. So it means that the constant term for this particular graph will be 1. And this is the example of the graph that has been drawn. And look at the axis of symmetry. We have x equal to minus into bracket minus 6 over 2 times 3 to give us 1. So you look at the axis of symmetry, which is x equal to 1. These are the part of a quadratic curve. Now, let's move to the next section of finding the vertex, that is the maximum value or the minimum value using the formula. This time, you are not going to use a graph to find the vertex, the maximum value or the minimum value. Note, the maximum value is the value of y that is the greatest. That is, you only get the maximum value when the quadratic function is maximum. That is, it is in the form of n shape. The coefficient of x squared is negative. And you only get the minimum value when the quadratic function is minimum. That is, we are talking about the least value of y. And they all happens at the turning point. So we are talking about the y value of the turning point. This time, we are not going to use graph, we are going to use calculation, a formula, to find the turning point, the maximum value, and the axis of symmetry. So the axis of symmetry formula is in this form. To find the y coordinate of the vertices, it implies that y is equal to f of x. So we input the x, which is the axis of symmetry, into the function to get its respective y value. And the respective y value is going to be our minimum value or maximum value. So look at this particular example. We have f of x equal to x squared plus 4x plus 5. We have x to be the axis of symmetry, which is minus 4 into bracket 2 times 1 equal to minus 2. And here, when you substitute the minus 2 as an input to the function f of x, the results will give us 1, indicating that the minimum point, that is the vertices, is minus 2, 1, as it is shown on the graph. We didn't use the graph, we used the calculation aspect as it has been calculated here. And here, the minimum value is 1 because the least value of y is 1 and the axis of symmetry is -2. Now let's move on to finding the vertices using the standard form. We also have the standard form, which is in the form of a square that has been completed. So we have a into bracket s minus h all square plus k. In this form, we learn how to simplify or bring down the function into this particular standard format. So by completing the square, the quadratic function can be expressed as f of x equal to a into bracket s minus a square plus k, where the vertex is at the point h and k. So the h is the axis of symmetry, the k is the maximum value or the minimum value. So here the maximum value is at k. That is when y is equal to k if a is less than 0, and y, which is k, becomes the minimum value if a is greater than 0. So let's see a simple example at this section. We have f of x equal to x squared plus 4x plus 5. F of x in this form, if we want to complete the square, it means we need to create a perfect square from this quadratic function. So how do we create a perfect square? First, divide the 4 into 2. So 4 divided by 2 will be equal to 2. In this format, we are going to square the 2, add to the expression, and also subtract. When you do this, it means that you've added nothing to the function. It's just 0. 2 square minus 2 square give us 0. We do this in order to complete the square. So how do we create a perfect square? We create a perfect square using this x and the 2 that we have here. So s plus 2 all square will represent everything at this section. And we find the value of this 2 square, that will be 4 plus 5. When you simplify, you end up getting x plus 2 all square plus 1. At this point, a is equal to 1, h should be -2, and k is 1, because when you compare this standard form to this particular expression, your a is 1. That's the coefficient of the perfect square, and the x is here. H is -h is 2. So when you make h the subject, it will be h equal to -2 and k is 1, which shows that hk, which is -2, 1, becomes the vertex, and the minimum value is y equal to 1. Now let's look at this application question where we are to find the maximum profit and the number of units to should they sell to maximize the profit. We can use the formula method where we have to find the axis of symmetry to locate the A, the B, and the C. In this form, when you substitute B and A and solve the axis of symmetry, the x will be equal to 10. And when you substitute the 10 into the function, which is p of x, we end up getting its respective y value to be 500. So as such, the maximum profit is 500 and the company must sell 10 units to maximize the profit. And at the same time, we can also use the standard form to also get the same response. But in this case, we have to make sure we have completely factorized the coefficient of s square, which is -5, to make sure coefficient of s square is positive. So here will be s square minus 20x. So when you divide the 20 by 2, it becomes the -10. We square it, add, and also subtract. Then create a perfect square with the x and the -10 in this form, and also multiply the -5 across the bracket to obtain -5 x minus 10 all square plus 500, which k will be the maximum profit and h represent the number of units. Now let's come to the practice section. Here you have to pause the video, try your hands on these particular examples, find the vertex and the maximum value of the function in this particular state, then use the same idea to also deal with this particular application question where you are to find the maximum height reached, and you have to also locate how does it take to reach the maximum height and how many seconds will the ball hit the ground. So this is a practical example for you to try your hands on quadratic function, how to find the turning point, the vertices, the maximum value or the minimum value. Thank you. Don't forget to subscribe to this particular channel for us to keep on giving you the best of maths education. Thank you.